Alright, now that we've collected the data, we need to plot it on a graph so that we can see what the relationship is between the voltage and the current. And so to do that, there's a program that's installed on your computer. It's called Logger Pro. So if we find that program and we open it, we get a window that looks like this. It has a large graph area that takes up most of the screen, and it has a little spreadsheet area on the left for the data. And it's automatically set up to have the axes labeled Y and X. However, in our experiment, our dependent variable wasn't called X, it wasn't called Y, and our independent variable wasn't called X. So let's change those. So we do this by right-clicking on the top of the columns in the little spreadsheet there, and we go to Column Options, and we go to Dataset X. And our independent variable was the voltage. That's the one that we changed in a controlled way. And the short name for that is V, and the unit for that is the volt, which has the short name capital V. We do the same thing. We right-click on the Y, we go to Column Options and Dataset Y, and our dependent variable was the current, which has the symbol capital I and the unit amps, or A for short. And by the way, we always plot the current on the y-axis, and we always plot the dependent variable on the y-axis and the independent variable on the x-axis. And now we're ready to enter our data into this little spreadsheet. So in the first box we're going to put 0, because when we had no voltage we also had no current. And then when we had 2 volts we also had 0.2 amps. When we had 3.5 volts we had 0.34 amps. When we had 5.5 volts we had 5.0 amps. When we had 7.5 volts we had 0.7 amps. Okay, so that's all of our data entered, and you can see here clearly that we've made one mistake. So that's here, because that was only 0.5 amps. Okay. Now if we look in the corner of the graph, we can see that a little red line has appeared. However, the scale of the graph is totally out of proportion. So what we need to do is just rescale our axes, and we can do that really quickly by clicking this Auto Scale Graph button, which is like a little A in a pair of axes. So if we click on that once, the axes are rescaled so that our data takes up as much space on the page as possible. Now that looks like a reasonably straight line. What this program does is it automatically joins the dots between the points, and we don't really want to do that in physics. We just want to have our data points, and then we can decide what the line should look like. So if we right click on the graph and then go to Graph Options, we can untick Connect Points, and that will just leave tiny little dots for each data point. But if we add point protectors, it'll put a little circle around each point so that we can clearly see where each point is. And then click Done. So now we can see all of our data points on our graph. We can only really see half of the top point. So what we'll do is we'll increase the scale slightly on the x-axis, and to do that we just click on this number 10 here, which is the highest number on the x-axis, and then it'll automatically turn into an 11, which is the largest value that's shown. We'll change that to 12 so that our scale goes slightly beyond the last point so we can see the whole point. Alright, so that's our data. Now in order to fit a line to this data, we note that it is a straight line relationship, and it does appear to go through 0, 0, and so presumably this is like a directly proportional relationship. And so we go to this Analyze drop-down menu, and under Analyze there are there's this option for a curve fit. Now, even though it's not technically going to be a curve, the type of line that we want to fit to these data points is here. So click on curve fit, and it gives us these options. AV is proportional, MV plus B is linear. We're thinking that this is probably a proportional relationship, and we have many more kind of advanced relationships possible here. But let's go for let's try the proportional fit. And so it gives us a little preview here, and that looks pretty good. So let's go with that fit. And there's our straight line. And it also gives us some information. So we have here I is equal to AV, where A is the gradient. I is our Y variable, current. V is our X variable, voltage. And A is going to be the gradient. So if you think about, if you relate this to your maths, this is like Y is equal to mx, which is a straight line with a 0 y-intercept. And so the gradient is just A. And here we can see that the gradient is 0.09716, so pretty close to 0.1. And so we can get a lot of data without having to do much work using this program.